Hello everyone, I'm Brandon Ordonez from ECE31 and today we're going to perform our experiment number 3 for our Digital Electronics Laboratory. Brandon's Vlog.
The objectives of this experiment are to demonstrate how to create delay using delay polling and to demonstrate how to create delay using interrupt. Alright, so now let's proceed with the experiment. The first part of the experiment is about delay polling. So let us open MPLAB XIDE and create new project. So after clicking finish, go to tools, embedded, MPLAB code configurator. And after that, click save. There. So for this experiment, we are told to use pin 7 from port A. So let's click that. And for the system module, oscillator select, high frequency internal oscillator, high frequency internal clock 4 MHz, clock divider 4, and low voltage programming enabled. Next, go to pin module and uncheck the analog and only check the output box. So rename your LED as D5_LED. So after that, go to device resources and go to peripherals and go to timer, add timer 0. So now that timer 0 has been added, edit the configurations. So for the clock prescaler, 1 is to 256. For the post scaler, 1 is to 1. Timer mode, 8-bit. For the clock source, FOSC over 4. And requested period should be 250 ms. Then after that, click generate. So after generation is complete, go to projects, experiment 3, source files, main C. So after opening main C, go to while, go to the while loop and add your code. So after writing your code, click build. So after build is successful, now go to MPLAB X IPE. Then after MPLAB IPE has opened, we will now program our PKit. So now we would be programming our code to our PKit. So we would use a PIC 16F18875 IC for our experiment. So let us now program. So now let us plug our PKit to our personal computer. Now that we have plugged our PKit to our personal computer, it is now recognized by the system. Click connect. Power and 3.125. Power target circuit from PKit 3, and select your hex file. So after hex files loaded successfully, click program. So after programming is complete, click disconnect. Now that programming is complete, disconnect your kit from your personal computer and unload your um, unload your microcontroller. Now let us build our circuit. Since we have used our A7 for our experiment, it is placed on pin 13. Here, and connect your output to the ground. Now, connect the VDD on pin 11 to the positive terminal, VSS on pin 12, to the ground, and VDD pin 32. So now we are ready to connect. Now that the circuit is finished, we are now ready to connect our microcontroller to our voltage source. Connect the positive and the negative. Now let's attach our power source to our outlet. So we can see now that our LED lights up for every 250 milliseconds. It is 250 milliseconds since from the requested period using timer 0, we use 250 ms. So part B of our part 1 is to modify the code in main C such that the LED will blink at 2 seconds interval using timer 0 polling. Explain your code below. So let's go to MPLAB X IDE. For the clock prescaler, edit it into nearest to 2 seconds. So almost 2000. And edit your timer period to 2000 ms since it is equivalent to 2 seconds. So after that, click generate. So after generation is complete, go to projects, main C, and build. So after build is successful, would you like to reload your hex file? Reload. Go to MPLAB XIPE and program your microcontroller. So now that we have connected our PKit to our PC, click connect. Okay. And since we have already reloaded our hex file, we should only click program. So after programming is complete, disconnect and build your circuit. So now that we have connected our microcontroller to our circuit, let us see the results. So from here, you could see that our LED lights up after 2 seconds and turns off after 2 seconds. So it lights on and lights off after an interval of 2 seconds. So for the second part of the experiment, we will be using timer 0 using interrupt. So first, let's build new project. Finish. After clicking finish, go to tools, embedded, MCC, and click save. So here we would select will select pin module, seven, port A7, then settings the same as before. For the system module, for the pin module, I'll name this as D5 underscore LED, uncheck the analog, then go to device resources, timer 0. So after adding timer 0, go to interrupt module and enable time R0, time RI. So after that, select this as 1 is to 256. Enable timer interrupt. Change this to FOSE underscore 4 and change this to 250 milliseconds. After that, click generate. After generation is complete, go to projects, experiment 3.2, source files. First, go to main C and enable global interrupt and peripheral interrupt. After enabling those, go to MCC generated file, tmroc. First, add here hashtag, include mcc.h. After that, look for time R0 underscore ISR and add your code. Live underscore toggle. So after that, click build. After build is successful, go to mplab x IPE. And after that, attach your PKit. So now let's connect our microcontroller to our PKit. After connecting your microcontroller, click connect. Okay. Go to settings, advanced mode, microchip, power 3.125, then operate, click connect again. Okay. Then after being connected, browse for your hex file. Experiment 3.2, this default production. After finding your hex file, click program. And disconnect. So now let us add our microcontroller to our circuit. So now that we have added our microcontroller to our circuit, connect our outlet. So as we can see, the LED blinks every 250 milliseconds. It is impossible to count, but it blinks before 1 second. So ideally, it should blink for every 250 milliseconds. So 1/4 of a second. So for the last part, we are asked to modify the code in the main C such that LED will blink at 2 seconds interval using timer 0 falling. Actually, it should be interrupt. So now, go to mplab x IDE, resource management, timer 0, this should be 1, 2, 1048, change this into 2 seconds. And interrupt module, check those, click generate. So this would appear. So first, replace so that should be it. After that, click generate. So after generation is complete, go to projects, tmro.0, make sure that mcc.h is included. Go to tmr isr. Now here we would add again our code. We have d5 underscore led underscore toggle. And after that, click build. So would you like to reload your hex file? Yes. After build is successful, connect your microcontroller to your PKit and go to MPLAB X IPE, click connect. And click program. So after programming is complete, disconnect and attach your microcontroller to your circuit. So after connecting your microcontroller to your breadboard, connect your power supply to your outlet. Observe the results. You could see that the LED turns on and off after every 2 seconds. Length of 2 seconds. 1, 2, 1, 2. Conclusion. The experiment had explored the use of polling and interrupt using MPLAB X IDE for the application of delay. Instead of using delay as an input in the code, polling used an internal timer in order to automatically toggle the output LED for 250 milliseconds and 2000 milliseconds. On the other hand, interrupt also served as an alternative when it comes to using the delay command, where it uses the timer 0 module when triggered by overflow of interrupt. Both the polling process and interrupt process produce the same output as seen from the experiment.